going to talk about free energy, or perpetual motion, or whatever you want to call it. And I'm going to use inverters and batteries to do the demonstration on free energy. I'm going to tell you that it doesn't work. There is no such thing as free energy. Most of you probably already know that, but I'm going to demonstrate this anyway because I've gotten a few comments about hooking up an inverter to a battery charger to your batteries, and hooking your inverter up to your batteries, and so on. So I'm going to demonstrate that procedure here and show that it doesn't work, and maybe we'll come to some interesting conclusions on efficiencies and whatnot. So I'll show you the setup I have and we'll get started. Over here I have a battery charger. It's a really good quality one from Iota. It's kind of the type of unit that you would find in an RV to charge its batteries. It's rated at 45 amps, really does closer to 50. Here I have two deep cycle batteries. They're fully charged and in good condition. This charger is currently hooked up to them, hence the green light. Charging them up to make sure that they're full before I start this test. This is a brand new pure sine wave 3000 watt inverter from Kotek that I just received in the mail. I was testing it out and I thought, you know what, let's just do this video here. It's a pretty nice inverter. And over here I have two power meters. These are both kilowatt hour meters or just watt meters, however you want to use them. I've compared them both by plugging them in end to end. They are pretty well the same. And I've also compared them against more scientific equipment, and they are within less than 1% error. So I'll be using those and my digital multimeter. So the general setup here is that I'm going to power this inverter off of these batteries, and I'm going to take my charger and plug it in to the inverter, hence getting free energy. Well, it's not going to be free energy, and I'm going to demonstrate that, but how much do you really think I'm going to lose? We're just going to have the power go around in a circle here between all three of these items, and we'll see where the losses are and how much we actually lose. Alright, let's give this free energy machine a test. I have my battery charger still plugged into wall power connected up to the batteries. These batteries are going through a current meter over here through these 2-gauge cables, which will be adequate for this application, to my 3 kilowatt pure sine wave inverter. It's going through this power meter. I realize you only need 1 meter for this, so I'm not going to use that one. I'll use this 1 meter, and I'm going to plug my battery charger into it. When I do that, the inverter will power the battery charger, which will charge the batteries, which will power the inverter, and so on. So, what's going to happen here? Are we going to open up a new wormhole into an alternate universe, or discover what the oil companies are trying to hide from us, or what? Well, let's find out. The batteries are fully charged, by the way, as evidenced by the light that's not blinking there. So, let's turn the inverter on, and this whole thing will be run in a continuous loop. And there we go. The whole system is running. We have to wait a little bit for the batteries to stabilize. You can see that the inverter current just keeps going up and up and up. It started at 40 amps or so. Now it's at 70 and holding steady. So let's take my multimeter quick. Put that on DC volts. And I'm going to check my battery voltage. Because as long as they're pulling power out of the batteries, this whole test is invalid. So we need to have everything in equilibrium. My batteries are still at 12.75 volts. We're going to wait a little bit for this system to stabilize, because this charger hasn't kicked in yet. Once it does, then we'll start taking some readings. While we wait for this system to stabilize, I'm going to show you what I'm going to record here. I'm going to record the inverter input power. For that, I'm going to measure the volts and the amps on the input. I can multiply them together to get the watts input and the inverter output power, which I'm just going to read off of this meter, which is plugged right into it. The charger also has an efficiency, so I'm going to read the watts in, which is just what this meter is providing, since that's feeding it directly. And the charger output, which is volts times amps, equals watts. And I'm also going to see what kind of loss I have in my cable. So I'm also going to write those numbers down. Now, I believe that this system is pretty well stabilized. It's holding at around 72 amps between the inverter and the batteries, which means that the voltages have pretty well stabilized here. The charger is nice and hot because it's running at absolute full power right now. So let's start taking some readings. My inverter, I want to know the input voltage and the input amperage. So let's measure that. Over here to my battery, and we are at 12.4 volts and 72.1 amps. Now I want to know the inverter output power. For that, I just read this meter, which is probably too dark for you to read, but it says 772 watts. So 772 watts. That's also my charger input power, since that's powering the charger. And now I want to know what my charger output power is, which is just volts times amps once again. So I'll take my clamp meter, take it off of there, read 0 again, clamp that onto the power going into the batteries, and this charger is powering my batteries at 49.8 amps. Very well. 49.8 amps, and we already measured the charger output voltage because that's just the battery bank voltage, which is 12.4 volts. Now, I did include the cable losses in the inverter losses here, and I did that by measuring at the batteries, not at the inverter. So let's see what that difference is here. I'm going to go straight to the inverter input terminals and measure it right there at the input terminals. So we are at 12.21 volts here at the inverter. Volts in is 12.4 volts. So now let's calculate all these wattages that are missing and see where our losses are. So the inverter input is 12.4 volts times 72.1 amps. That is 894 watts. Okay, and I'm also missing my charger output wattage. So let's see what that is. We have 12.4 volts at 49.8 amps. 618. And the cable loss is over here. So we have 12.4 volts minus 12.21. So my cables are losing 0.19 volts. If I take 0.19 and multiply that by the amperage, 72.1, I can see that my cables are losing 14 watts. So my inverter was outputting 772 watts, so I'll take 772 over 894. I can find that my inverter efficiency in this particular application was 86%. But if I take 894 and subtract out 772, I get a loss of 122 watts. That's the loss in my inverter. How about the charger? Let's see how efficient that was. The input power was, well, let's start with the output. So the output power was 618 watts. Divide that by 772, which is the input power, and my charger is only 80% efficient, which is actually very, very good for a charger, by the way. 80%. It's a very high quality charger. So what are the losses? Well, 772 minus 618. I get 154 watts lost in the charger. How about that cable to the inverter? Well, 14 watts. So there's all of my losses. How much was I losing in this perpetual motion setup? Well, 122 plus 154 plus 14. 290 watts. There you go. My perpetual motion machine has failed. I've actually been burning 290 watts. I've disconnected my entire setup here. The charger is now running off of wall power, recharging my batteries, and that's because that 290 watts came out of the batteries. These batteries were powering this thing. We were pulling 290 watts out of them because that is exactly the amount of losses that we were incurring in this setup. The inverter was losing some, the cabling was losing some, the charger was losing some, all the connections were losing some, additional spare losses that I didn't account for, but overall, about 290 watts were lost in this setup. So, connecting a charger to an inverter, to a battery, this whole loop doesn't work. Not surprising, but I thought this might be interesting anyway for other people, just to see how you calculate efficiency for these sort of things, what kind of efficiency to expect. Upper 80s in the inverter, about 80% in the charger if you have a good one, could be as low as 50 if you have a cheap one. And cabling, 14 watts isn't unreasonable for 2-gauge cables and 70 some amps of current. So, yes, no such thing as perpetual motion, or free energy, or anything of the sort. I'm sure there's plenty of videos out there on that. I've actually gotten a few comments on this, asking what would happen if you connected a charger to an inverter to batteries, and the batteries to the inverter. Well, this is what would happen. You would drain your batteries at around a 30 amp rate. And with that, this is Neural Nar. Thanks for watching.